The bubble sort is another sorting algorithm with a very similar runtime to selection sort. It can run in a faster time than selection sort, but on average it still takes that n times n minus 1 over 2, or n squared over 2, or just n squared if we're looking at notation for complexity. So I'm going to perform a bubble sort here. The bubble sort will do n number of passes, so in this case it will do 6 passes, and with each pass the largest number will be at the end. The difference with the bubble sort is that it doesn't compare every single number to every other number, so there is total less comparisons, but there are also more swaps, as you'll see. So what we do is we look at that first number there and we pick it up. We compare it to the one next to it. The 5 is less than the 7, so we don't need to swap. Now we're looking at the 7 and the 3. The 7 is greater than the 3, so we swap. Now we look at the 7 and the 6. The 7 is greater than the 6, so we swap. Now we're looking at the 7 and the 1. The 7 is greater than the 1, so we swap. Now we're looking at the 7 and the 2. The 7 is greater than the 2, so we swap. The 7 is at the end. That has been sorted. Now we go back to the start, and this is our second pass. The 5 is greater than the 3, so we swap. And we look at the 5 and the 6. The 5 and the 6 are in order. There's no swap needed. Then we look at the 6 and the 1. The 6 is greater than the 1, so we swap. Then we look at the 6 and the 2. The 6 is greater than the 2, so we swap. We're at the end. There's no more comparisons to be made because we ignore this sorted part of the list and mark that as sorted. Now, as you can see, each pass through the list, the highest number bubbles up to the top. That's why it's called a bubble sort. If we go through it a third time, that's the sorted part, we're comparing these two. There's no swap needed. The 5 is greater than the 3. We look at this, the 5 is greater than the 1. These two swap. The 5 is greater than the 2. These two swap. And there's no more comparisons to do. We mark that as sorted. Back to the start, the 3 is greater than the 1. Then the 3 is greater than the 2. So we swap. There's no more sorted, there's no more comparisons, so we mark that as sorted. We look at the last two. The 2 is greater than the 1, and then we're down to one element which can't be compared, so we consider that sorted, and the entire list is now sorted. There was a lot less comparisons there overall, but there were a lot more swaps than were in the selection sort. Overall, bubble sort will run in the same amount of time as the selection sort, especially for large amounts of data. The next sort that we're going to look at is the insertion sort, which is a much faster algorithm. And then I'm going to look at quicksort. I'm not going to use the cards for quicksort because it's best demonstrated with a larger set of data. So I'll use some miniatures for that, and we'll sort them by size.